Welcome to this Maths Made Easy video on position vectors. And to start with, let's just take a look at working with position vectors. So here, if we have a point A, the position vector is denoted OA. So we denote it as OA with this little arrow above. Okay, so that's the position vector OA. Now we can see that from this diagram here. If this is O, then the position vector OA is given like this. Okay, and similarly, the point B here, and again, using this diagram to see that, then the position vector for point B will be denoted just in a similar fashion here, but instead replacing the A for B there. Now, by writing points as position vectors, we can then describe vectors between points as position vectors. So here, let A be equal to the position vector of A here, OA, and B. So B is equal now to the position vector OB. So in that case here, we can see the vector AB, the vector AB here, is given now as minus OA. We're going backwards here, so that's minus OA, minus the vector OA there, plus the vector OB. Okay, so plus the vector OB. Okay, and then replacing our OA here with minus A and our OB with B here, we can write that as minus A plus B, or in a similar fashion here we could write that as B minus A. Okay, and we can see that visualized here on this diagram. So that gives us everything we need there for working with position vectors. Moving on now to describing vectors using I and J units. So to start with, a vector with magnitude of 1 unit is called a unit vector. So let's just denote that. So a vector of magnitude 1 this is called the unit vector. Okay, so this is the unit vector. Okay. The standard unit vectors are I and J. So I and J are our standard unit vectors. Now these are in the x-axis and y-axis respectively. So unit vectors are I and J. And these represent the x-axis here and the y-axis respectively. So x-axis and y-axis respectively. Okay, just note that down. And these standard unit vectors are used to express the horizontal and vertical position of the end of a vector compared to its start point. Now let's take two vectors here. Let's say we've got A, which is 3i here, so let's just denote that actually. Let's get rid of that 2 there. Let's write this as 3i. So that's 3i plus 5j. And B here as 5i plus 2j. Well, to write the vector AB here, so to write the vector AB, that's simply going to be minus 3a plus 5g, so it's going to be minus 3i plus 5g, plus this vector here, b. Okay, so plus 5i plus 2j there. Okay, now we simplify here, this is minus 3i plus 5i, giving us 2i there, and minus 5j plus 2j, giving us minus 3j there. Okay, so that gives us everything we need there for describing vectors using I and J units. And finally, let's take a look now at column vectors. So if we've got the vector A here, which is equal to 4i minus 3j. Well, if we express this as a column vector, that would simply be A, and as a column vector here, this would be 4 minus 3. Okay. Now we can simply add column vectors in a nice, easy way. If we've got the vector A here, and let's just denote this in a different colour. Let's say we've got A, which is 5 minus 2. And let's say we've got B here, which is 1, 3. Then if we want to add these two vectors together, that would give us A plus B. And when we add two column vectors together, all we simply do is we add the two top elements together, so that's going to be 5 plus 1. So our top element here will be 5 plus 1. And then for the y component here, the bottom element, we're going to do minus 2 plus 3. And in that case, minus 2 plus 3 would simply give us 1 there. So minus 2 plus 3. So that's going to give us 5 plus 1, which is 6, and then 1, like we just said there, for our y component. Okay. And when we're multiplying a column vector by a scalar, again, this is rather straightforward. Let's say we've got C here, so let's just change our pen colour. So if C is given as minus 3 4, well, in that case then 3C here, we just take 3 and we times it by the minus 3 here, and then take the 3 again and times it by the 4. So this is going to be 3 times minus 3 and 3 times 4 there. Okay, well in that case 3 times minus 3 gives us minus 9, and 3 times 4 gives us 12 there. Okay, so that gives us multiplication by a scalar there for column vectors. So that gives us everything we need for column vectors, and that concludes this Maths Made Easy video on position vectors.